Okay, good morning everyone. Let us begin today's session. So in week 5 we learned about is a relationship and inheritance in C++. So is a relationship and inheritance. And then we learned about how the data members and member functions are affected in this inheritance. Okay. And then constructors and destructors, how are they affected in case of inheritance? And then uh, we looked at how to model a phone hierarchy in C++, and then we also looked at private and protected inheritance. So what is this is a relationship? In some places it is also written as this, okay, is hyphen a. So the thing is that in the real world we often find that one object is a specialization or a generalization of another object. Okay, so oftentimes in the real world or uh, yes, oftentimes in the real world we find when we model these real world objects in the form of classes, we often find that one object is a specialization, or you can say that generalization of another object. Okay, for example, a red rose is a specialization of a rose, and a rose is again a specialization of a flower. Okay, then so here we can see that this is a kind of uh, chained relationship, because the red rose is a specialization of rose, and again rose is a specialization of flower, but that need not be the case. We can also have this kind of relationship where we have three-wheeler is a specialization of a vehicle, and again a two-wheeler is also a specialization of a vehicle. So if you follow this method, then you will see that it will form a kind of tree. Okay, so like if you assume that uh, some object can only be the specialization of one other object, so every object will have one parent, then it will form a kind of tree. So so this fact that one object is specialization of another, so OOAD, so OOAD, as you know, is object oriented analysis and design. So OOAD models this using a is-a relationship. And now coming to C++, so C++ models this by inheritance of classes. So there is a mechanism called inheritance by which we can model this uh, is-a relationships. Okay. So what is the semantics of inheritance? So for these next few slides, I will assume this kind of a uh, relationship. So we have a base class, and we have a derived class. Okay, and the derived class is a specialization of the base class. So firstly, from the previous slide, we can say that the derived is a base. So basically, derived is a specialization of the base. Next, we come to the data members. So the derived class, the derived class inherits all the data members of the base class, and the derived class may add data members of its own. So basically, if you have some data members in base class such as xyz, okay, the same data members will also appear in the derived class. Okay, but the derived class may have some additional members also. Then we come to the member functions. So similar to the data member case, so the derived class inherits all member functions of the base class. Okay, and then the derived class may override a member function of the base class by redefining it with the same signature. And similar to that, okay, so the base derived class may also overload a member function by redefining it with the same name but different signature. And again, the as usual, the derived class may add new member functions. So for in the case of member functions, we have four cases. So one thing is that it will inherit all the member functions of the base class, like the data member case, okay, and it can also add new member functions. But the thing is that if you have a function in the base class, then if you redefine the same function in the derived class with the same signature, then the behavior of that function will be redefined with the new thing. Okay, so that is the case of overriding. But if you redefine it with a different signature, then it is similar to function overloading. Okay, so that is the case of the member functions. Next is that access specification. Okay, so we all know that there are three access specifiers: uh, public, protected, like public, private, and protected. Okay, so how does inheritance affect these access specifiers? So the thing is that the derived class cannot access the private members of the base class. Okay, so cannot access the private members of the base class, and the derived class can access the protected members of the base class. So basically, what you see is that uh, the public members, they are accessible by all. Uh, Next, we have the protected ones. So you can see gradually it becomes uh, more restrictive basically. So the public members, they are accessible by everything. Okay, they are accessible by all the things such as other classes, other functions, global functions, anything. The protected members, they are only accessible by the derived classes. Okay, so within the inheritance chain, those members are can be accessed, but the private data members, they cannot be accessed by even in the inheritance chain. So even in the derived classes you cannot access them. And now next, coming to the construction and destruction. So this is very important. Okay, so the constructor of the derived class must first call a constructor of the base class. So constructor of the derived class must first call a constructor of the base class to construct the, okay, whatever, construct the base class instead of the derived class. And the destructor of the derived class must call the destructor of the base class to destruct the base class instead of the derived class. Okay, so basically when you so this when you see that this derived is an instance of the base. Okay, so basically you will have a small base class within the derived class. Okay, so you know that you can see from all of these things that the all of the data members of the base class, they will be there in the derived class, and all of the member functions of the base class will also be there in the derived class. So in a way, the derived class contains a small base class, and surrounding it there are some additional functionality, additional data members and additional member functions. So the base class, like the derived class, it adds adds additional things on top of the base class. Okay, now when you are constructing it, okay, when you are constructing an object of this class, you must make sure that you construct the base class also as well. Okay, so every constructor of the derived class, it must first call the constructor of the base class. Okay, when the base class is initialized, after that you can initialize the derived class data members. Okay, and the derived class destructors, okay, all of the destructors of the derived class, they must also call the base class destructor. Okay, next is uh, wait, okay, so this is a detailed slide about the protected access specifier, which I went over in the previous slide also. So again we can follow the same diagram. So we have this base class and then we have a derived class like this. So normally the derived class members cannot access the private members of the base class, and the derived class members can access the public members of the base class. Okay, this is obvious. Then we also another have this, we have this protected access specification. So in this case the derived class can access the protected members of the base class, and no other class or global function can access the protected members of the base class. Okay, so some outside function or class, it cannot access this base class data members. Okay, so protected member in the base class is like private in other classes or global functions. Okay, so I hope that's clear. Then we come to constructors and destructors. Again, let me draw the diagram. And also we have, there is another diagram. So the derived, every derived class contains a small base class. Okay. So the you must remember that the derived class does not inherit the constructors and destructors of the base class, but it must have access to them. Meaning that the base class constructors and destructors, they should have protected access. Okay, you cannot have private access, because then you cannot initialize the derived classes. And the derived class must provide its own constructor and destructor. And finally, the derived class cannot override or overload a constructor or destructor of the base class. Okay, so you have three criteria. So the constructors and destructors, they are not inherited, but you must have access to them, meaning that they should at least have protected access. Okay. uh, Ideally constructors should have public access, obviously, but at least you should have protected access. And the derived class must also provide its own constructors and destructors, since they are not inherited, and you cannot override or overload the constructors of the base class. Okay, then I come to the cycle of constructing and destructing. So the constructor of the derived class must first call the constructor of the base class. Okay, so before you initialize any of the variables in your derived class, like you have this initializer list in your constructor. You first initialize the base class, and then you initialize the other variables. Okay, so when you have to construct this object, first construct this small object. Okay, construct this small base object and then initialize the other variables. In case of destructor, so in case of destructor, the order does not matter. Okay, you can do it in a way that makes sense. Okay, but you must call the destructor of the base class. Okay, so you can do it while destructing, you can do it in a way that makes sense, but you have to call the destructor of the base class, because then what will happen is that the base class might have been allocated some heap memory, so you might forget to release that. Okay, the base class might have some heap memory stored in some private pointer or something. Okay, and you cannot really destruct it from the derived class. Okay, so that might cause a memory leak, so you must call the destructor also. And now we come to the exercises. So this is the first exercise. Okay, let us go over the solution. So before coming to the solution, I want to discuss one more thing. So I remember that the derived classes, they all contain a small base class. Okay, one thing is this, and the other thing is that when you create an object of this class, the memory layout is somewhat like this. Okay, so the how is it stored in the memory? Okay, so the base class, the small base class, it is stored first, and then the extra data members are stored after that, and this whole thing becomes the derived class. Okay, so you have this base class in the beginning, and then you have the extra members here, and this together forms the derived class. And so if you have a pointer to this location, if you have a pointer to this location at the beginning of the memory, uh, that pointer can refer to both a base object and a derived object depending on how you interpret it. Okay, so the same address, okay, let us say you have a pointer p, and this is the same address. Okay, if you write it as base star p, then it will work in one way. Okay, if you write it as derived star p, then it will be interpreted as a derived object. Okay, so like these are two things to keep in mind. Okay, it might be required in few further questions. Okay, 1 minute. Okay, so in this question we have a class C1, like my class 1, with a static data member x1 and a non-static data member x2, and then we have a function which just prints fun, and then we have another class which inherits from my class 1, and it adds another data member called dl. And then, so like if we draw the class hierarchy, then we have my class 1 with the data members x1 and x2. Then you have my class 2 with the data members dl. And then my class 2 inherits from my class 1. Okay, and here we also initialize the static data member x1. Okay, now coming to the main function. So in the main function we basically create an object of my class 2, and we print the size. So you have to say basically that what is the size of this object which contains the three data members. So for this you must remember that double values, they occupy 2 bytes. No, sorry, wait. Okay, so double, there you know they're 64-bit integers. So basically they occupy 8 bytes. And integer is a 32-bit number, 32-bit data type, which occupies 4 bytes. So looking from this diagram, there are 3 data members. So it should occupy 4 plus 8 plus 8. Okay, so it should occupy 20 bytes, and that should be the answer. But here there is a catch here. The catch is that uh, x1 is a static data member. So static data members, they are unique because they are usually not counted in the object size. And why is this the case? Because as you know that the static data members, they're shared between all of the objects of the class. So in a way, the static data member, it is a member of the class and not a member of the object. Okay. So if you have let us say three objects, okay, all of them have one copy of the static data member, let us say x1. So all of them have one copy, like they don't have, they share the same copy of x1. Okay, so that is why when you write size of d, uh, it does not really count the static members. So if I ignore the static member, then the total space occupied is 8 plus 8, 16 bytes.
So
Yes.
I have a doubt. In previous slide, it was written that constructor of base class should be called first.
Hmm.
So where it was written in this program, I didn't understand this
Okay,
program
okay.
actually.
So in this case, see, in this case, we are assuming that like we are calling the default constructors. So that is why. So see, what I meant is that if you have any custom constructor, okay, if you have overloaded the constructors or anything, then you call it first. Okay, if you don't call the constructor, then it will call the default constructor. Okay, so it will work.
Okay, sir.
Okay, now moving on to the next question. So this is the next question. Okay, now let us discuss the solution. So uh, in this case, you can see that you have a base class here, which has a protected data member n1, and then in the public access specifier you have the constructor which takes one value x and it initializes n1 to x. Okay, and then you have a function called f1, which increments this n1 and prints it, and then you have a derived class here which inherits from the base class. So again, like similar diagram. So here you can see that example. Okay, so you have this derived class constructor. Okay, it takes one value x and it initializes the base class with the same argument. So you can see that the base class constructor, it takes one argument. Okay, now of course there will be a default constructor also, unless you hide the default constructor by making it private. Okay, there will always be a default constructor. So it is not technically necessary to call the base class constructor, but if you don't call it, then the default constructor will be used. Okay, but you might not want that. You might want it to not call the default constructor. Okay, you might want it to call a proper constructor. So that is why what you do is, when you initialize the derived class, you first initialize the base class and then anything else. But since the derived class, it does not have any extra data members, so here we are not doing any other initialization. And then we again have a function f1 with a value a, and it does the same thing as this. Okay, now notice one thing, that the base class and the derived class, they both have the same function f1 but with different signatures. Okay, so this is a example of the function overloading. Now we come to the main function. So in the main function, we create a object small d of the type of derived type, and then we call d dot f1. Okay, so what is the output? So the correct answer here is that there will be a error here, because there will be an error here. Okay, and it is like a bit weird reason. There is uh, not not a lot of logic to it. Okay, so the d dot f1, we are calling it without any arguments. Okay, so it does not match the f1 function signature in the derived class. Okay, so since it cannot find it in the derived class, it will return that no function, like no matching function. Okay, it will return no matching function error. Okay, because there is no f1 function without any arguments. Okay, so the function signature does not match. But the main question here is then that, since the derived class, it inherits all of the member functions of the base class, then it should also inherit this f1 function of the base class, which takes no arguments. Okay, so it should find a matching function, right? But like for some strange reason, like there is no technical reason behind it, it is just the way that the language has been designed. Okay, so when you like in a derived class, if you overload or override any of the functions of the base class, then any of the overloaded versions, they do not appear. So let me write it down. So in the derived class, if you it not override because so basically in the derived class, if you overload any base class function, then the base class version, okay, base class versions. So if you in the derived class, if you overload any base class functions, then the base class versions of those functions get hidden in the derived class. So coming to the example, what you see is that in the derived class, we have overloaded f1, and f1 is a function of the base class also. Okay. So in the derived class, if you do this, if you overload this base class function, then the base class version, so in this case this one, so this version it is hidden from the derived class. Okay. So therefore derived will not have this function. Now there is simple way to fix this. So in the derived class we will have to use this line, okay, using base colon colon f. Okay, we have to add this line somewhere. uh, if you add this line, then the base class version will be also be like it will be there. Okay, it won't be hidden. So where do you add this line? You add it somewhere here. Okay, so you have to add this line. You have to add this line, like how do I say, you have to add it is this is like a function declaration. Okay, this is like a function declaration, so you have to add it outside any function. Okay, so this f1 is a function, but you have to add it outside any function, so you can put it here, okay, between the constructor and the function, or you can put it after the function body also, you can put it before the constructor also, but the point is that this is like a function declaration, so you have to put it in that space. So if you write this using base colon colon f1, then it will bring forward the base version of the f1 as well, and then this main function will work without any problems, and like as you know, it will then print the value of 11. Okay. Okay, so I hope that is clear. Now I'll move to the next question. Please solve on your. Okay, so now let us go with the solution. So in this, for this question, you have to remember this diagram. Okay, so this diagram that I drew here, so you have to remember that. Let me draw the diagram again. Okay, but like I'll draw the diagram here again. Okay, so in this question you can see that you have a base class with a, like in the public access specifier you have a function called print, which prints C. Okay, it just prints C. Then you have a derived class, okay, which inherits from the base class. Okay, it inherits from the base class, and then you again have a function called print, which prints C++. Now you can see that this, the function signature, it matches exactly. So this is a case of function overriding. So this is a case of function overriding. Now we come to the main function. In the main function you will see that we create two objects, one is of base type and one is of derived type, but you will see that we assign them both to base pointers. So we create two pointers a1 and b1, which we interpret as base pointer, and then we assign the base and the derived objects to these pointers, and then we call a1 dot a1 print and b1 print. Okay, so now what will be the output? So here you have to remember that diagram. So we have the base class, like how is the uh, how are these inherited objects stored in memory? You have to remember that. Okay, so you have the base class, and then you also have the derived class. So as you know, the derived class, it contains a small base class within it. Okay, and it, other than that, it contains some extra data members and all. Okay, so in the memory, the base class is stored in the beginning, and then the extra data members are stored after that, and this whole thing, it comprises the derived object. Okay, so if you have a pointer to this memory location, okay, so this is the memory location I'm referring to. So if you have a pointer to this address, depending on how you interpret it, you can interpret it as either a base, you can interpret it either as a base object or a derived object, depends on your interpretation. So in the first case it is simple. Okay, so we create a base object and we assign it to a base pointer, so it will behave as a base object only. Okay, in the second case we create a derived object, so this whole thing is created. Okay, so this whole thing that I drew, this is created, but then we assign it to a base pointer, meaning that it is interpreted as a base object. Okay, so the whole derived object, it is interpreted as a base object. Then we call a1 dot print and b1 dot print. Okay, now since both of the objects are interpreted as base objects, the base version of the print will be called. So this function will be called for both of the objects because both are interpreted as base objects. So therefore the output will be CC. Okay, output will be CC. So is this question clear? You might have a question that if b1 is interpreted as, like if b1 is interpreted as a base, okay, base object, and therefore the uh, base version of the print function is called. So wouldn't that cause any problems, because the object is actually a derived object? Okay. So one question might be that if the base print is called, then wouldn't there be any problem, because uh, the object is actually a derived object? Okay, so thing is that theoretically there should not be any problem. I mean, from the perspective of the programming language, okay, there should not be any problem, because every derived object contains a small base object. So you can take the small base object and you can use the base functions on it. Okay, all of these are, like, all the functions which are defined in the base class, they are the base functions. Okay, so you can take this small base object and you can run all of the base functions. It is technically possible. Okay, maybe it won't make sense logically, but uh, from the perspective of the programming language, there will not be any problem. And plus, this case, okay, uh, you can you will further be able to explore it in uh, dynamic polymorphism. Okay, where which function is called depends on what kind of object it is. We will explore it later. Okay, so this is the next question. Okay, now let us go over this solution. So there is one mistake here. Okay, so there will be a data member here. Okay, so now let's go. So in class A, you can see that it has a public data member A and a constructor which sets x, like which sets A equal to x. Okay, this x goes into A. Then we have another class B which inherits from A and it has a data member small b. Then you have a constructor which takes two values x and y and it initializes this small b and it also initializes the base class. Okay, uh, so here you can again see that the base class is initialized and then the data members are initialized. So in this initializer list the order does not matter. Okay, uh, because you know that the things are initialized in the way they are defined in the class. Okay, so if you write int bcd, okay, so then b will be initialized first, then c, then d. Okay, the order in the initializer list, it does not really matter. And since the base class is always at the beginning, okay, you know that from the memory layout you know that the base class is always at the beginning, so that is why the base class will always be initialized first. Now we come to the main function. So in the main function, we create two objects t1 and t2. We initialize t1 with 1 comma 2. Okay, so your 1 goes here and 2 goes here, so accordingly this will initialize as follows, which means that, so like this is how it will initialize. Okay, and for the case of the second object, we call the constructor with value of 5, so this will be 5. So t1 dot a, you can see from here that t1 dot a is 1. Okay, and from here you can see that t2 dot a is 5. So the numbers 1 and 5 will be printed. Okay, okay, then let us continue. So this is the next question. Okay, Okay, now let us discuss this solution. Yes, so one thing- okay, so here you can see that you have three very similar classes. Okay, and you can see that all of the classes, they have constructors and destructors, and in the constructor and destructors um, we just print that which class it is coming from. So for example, in the constructor we print a, and in the destructor of a we print tilde a, and similarly for b and tilde b and c and tilde c. So this question is mainly about the order of construction and destruction. Okay, and you can also see that b inherits from a and c inherits from b. So we have a, so b inherits from a and c inherits from b. Okay, and now in the main function we just create a object of the C class. Okay, so now uh, so since the C object is created, the C's constructor will be called. Okay, but before, so the C's constructor, it will first initialize, so you have to remember that C inherits from B. Okay, so first the B object will be initialized. Okay, and one more thing you must remember, that in case of constructors, first the initializer list is executed. Okay, all the variables are initialized and by the initializer list, and only then is the constructor body called. The constructor body is called after all the variables have been initialized in the initializer list. Okay, so when we are creating this C object, it will first initialize the B object. Okay, now to initialize the B object, again it will first have to initialize the A object. Now the A object is independent, it is not inheriting from anything, so it will get initialized, and then the constructor body of A will be called, which will print A. Okay, so this will print A, and then since the A has been initialized, now the B can finish the initialization. So after doing that, the constructor body will be called, which will print B. And then coming to the next thing, so uh, since B has now been initialized, the constructor body will be executed in C, so then it will print C. And then now we come to the end of the, so this, the object is initialized here. Okay, then it will run, the program will run, and over here the program terminates. So this obj object, it has to be destroyed. Okay, so how will it be destroyed? First the C objects, first the C object will be destroyed, then it will call the destructor of the B class. Okay, so since the C object is destroyed first, it will print tilde C, then the B object's destructor will be called, then B will be destroyed and it will call the destructor of A class. So the answer is this, ABC and then tilde C, tilde B, tilde A. So you have to remember this trick basically. So uh, if your inheritance pattern is like this, so inherits from A and C inherits from B, then the constructor call pattern and constructor and destructor pattern is like this. Okay, so first uh, the class which is at the base of everything. Okay, so the first class which is at the base of everything, first that will be initialized, and then other classes which derive from that, they will be initialized. Okay, like doing so it will come to the end. Okay, but in the case of destruction, what will happen is that first the derived class will get destroyed, and after that is done, then the base classes will get destroyed one after the other. Okay, so wait, okay, now moving on to the next question. Please try this question. Okay, now let us go over this. Now let us go over this question. So in this question, we have a base class with a static function that prints C++. Okay, and it's also in the public access scope. Then we have a derived class which inherits from the base class, and in the public scope we have a constructor, uh, and then the constructor body we have to fill, and then we have the main function, and in the uh, main function we are creating an object t1 of the derived class, and then we have to fill in the blank in such a way that it prints C++. Okay, so actually this question is a bit ambiguous because there are various ways to do it. uh, like we can, over here we can write here C out C++ only, uh, but if we want to call this function, basically if we want to call the base class function, then also we have various ways, like we can write here simply func. Okay, that will call this base class function and it will print C++. We can also, what we can do is we can write base colon colon func. Okay, this is allowed because see func is a static function, so it does not depend on does not depend on any object. Okay, and also there is another thing that within this within this context of base and derived classes, you can write base colon colon func even if it is not a static function, because like this is within the derived object, right? So you can do that. So these two options are there. Using this you can call the uh, you can call this function of the base class, and that will print C++. Okay, now let us move on to the next question. Okay, this is the next question. Okay, now let us discuss the solution. So in this question we have again we have two classes, A1 and A2. In A1 we have a public data member called T1. Okay, and in then we have A2 which inherits from A1, and it has a public data member T2, and it has a public function which returns T1 plus T2. Next we come to the main function. In the main function we create two objects B and D. B is of type A1 and D is of type A2. Okay, now we do B dot T1 equal to 10, so this will be set as 10, and then we write D dot T1 equal to 20, D dot T2 equal to 30. So in case of A1 this will be set as 10, and in case of in case of B this will be set as 10, in case of D this will be set as 20 and 30. So the output should be 50 here, but the problem is like actually this will not happen. Okay, there is a problem. The problem is that this inheritance, okay, this A2 which inherits from A1, this is a private inheritance. Okay, so private inheritance means that all of the data members in A, they will be private in A2. So if you create any object of A2, you cannot access the data members of A1 from outside. Okay, you cannot access it from outside the class. So specifically this line, okay, D dot T1, this will not compile, because see, D is a D is a object of type A2, which means that D is a object of the derived class, right? So, there won't be any output either. So uh, D is the object of the derived class. Now in the derived class, we are privately inheriting the base class, right? So since we are privately inheriting, we cannot access the data members of A1 class from outside. So here you can see that we are directly setting the values of A1 here. So that is not possible. So hence this line won't compile. Okay, so that is the answer, and there won't be any output either, obviously. Okay, then let us move to the next question. So this is the next question. Okay, now let us discuss the solution. So in this question, you can see that we have we so here we have to fill in the blank such that the output is 10. Okay, then we have one class B with a private data member X, and in the public access specifier we have a constructor which sets X to underscore X, and then we also have a function called fun with which returns the data member X. Okay, and then we have another class D which inherits from B. Okay, it inherits from B. In this D class we have a data member Y, and then we have a constructor D which takes two values underscore X and underscore Y, and then in the here also we have a function called fun, and this function fun, it calls B colon colon fun, and then it prints Y. Okay, and now we have the main function. Now coming to the main function, uh, we create a new object of type D, capital D, and we assign it to a D pointer, capital D pointer, and then we call b2 arrow fun. Okay, so basically we are calling this function. Okay, we are calling uh, see, b2 is a object of type D of the derived class. So when we are calling b2 arrow fun, we are basically calling the fun function of D class, so the derived class. And you can see this fun function, it prints b colon colon fun, and it then prints Y. And B colon colon fun, you can see that it prints X. So in a way, the that line just becomes this. So that line basically simplifies to this line: C out, arrow X, and arrow Y. So and now we want to print 10. So 10 has two digits, 1 and 0. So we have to basically set X to 1 and Y to 0. You can also see that in the constructor also we are passing 1 comma 0. So underscore X is 1 and underscore Y is 0. So we have to set X and Y to these values. So how do we do? We simply write here B, wait, because we simply write this. Okay, we write B and then in brackets underscore X, and then Y in brackets underscore Y. So what this will do is, see, first, so see, Y will be initialized as normally. Okay, Y will be set to underscore Y. In case of B, B's constructor will be called with the value underscore X. Okay, so with underscore X, B's constructor will be called, and then the constructor, will print the, wait a minute. Okay, so then the constructor will set the value of uh, X to underscore X, which is 1. Okay, okay. Okay, everybody. So that is all for today's class. So thank you for attending today's class. You may leave. Okay.